What's up, everybody? Mr. Cully here, and this is my first YouTube channel and my first YouTube video as a teacher. So basically, what this is if you weren't paying attention in class, or you just didn't care to listen that day, or you were missing, I'm going to give a rundown about what we learned that day. So it's pretty cool, pretty chill. I'm just sitting here. I'm actually a life hack, first of all. Pizza crackers. All right, you just get a Triscuit, not a Triscuit, you get a plate of Triscuits, some pizza sauce, some cheese, pop in the microwave for a minute, boom, you got dinner, and that's how you be a college student. So that's the most important thing that I want you to learn from me. Other than that, we got to learn physics. And so, what is physics? Last semester we learned about chemistry. Okay, that's chemical reactions, that's the periodic table, all that kind of stuff. Maybe you didn't like it, maybe you did. It's my favorite science, but we're moving on to something different called physics. So this is the PowerPoint I gave that day. If you don't know what that's from a movie. If you don't know the movie, you're already failing my class, all right? That's Inception. So that's the ending scene. That's a spinning top. So physics, when we talk about physics, one of the first things that may come to your mind is motion. You may know about Newton's laws of motion, and you might know about forces. We're going to get into that, but the first thing we're going to talk about is motion. So I asked this question in the class, all right? How can you tell if something is moving? And so I got some responses like, it changes position. And that's very true. So if something changes position, it must have moved. But it's deeper than that. So, for example, I asked, have you ever been in a situation where you could not tell if you or some other object was moving? And I got some responses like, maybe you're in a car and you look at the sun and you can't tell if you're moving or the car's moving. Some people said that. Um, but I went into this scenario, okay? Imagine you ride the bus. I know you probably don't ride the bus, but imagine you do. You're sitting next to your friend on the school bus. The bus is going a constant 30 miles per hour, all right? Pretty slow. You look over at your friend. You're both sitting down, all right? How fast are they moving? All right, you're on a bus going 30 miles per hour. You look over at your friend. You're both sitting still. How fast are they moving? Are they moving 30 miles per hour? Or are they moving 0 miles per hour because they're sitting still? So we have this question and we had this debate about whether or not they're moving at 30 miles per hour or they're not moving at all. So it depends on your perspective. Okay, to me, that person's not moving at all. But to someone who's watching the bus move, that person's going 30 miles per hour. And then I ask this question. All right, you're sitting down right now, probably watching this. All right, are you moving? Well, maybe, kinda, I don't know. And some people said, yeah, I am because the earth is rotating. And yeah, that's very true. We pulled up this website. Let's take a look. All right, so it's going to count seconds from when I open this page. And if you know anything about tectonic plates, they're the plates underneath the earth, the ground, that kind of shift the continents. And they move very slow, like 2 inches per year. So since we've opened this 13 seconds ago, we've moved 25 nanometers. All right, that's very, very few. But as some people noted, the Earth is spinning; it's rotating at about 1,000 miles per hour at the equator. Where we are in Ohio, that's about 800 miles per hour. So right now, we're moving at 800 miles per hour. We don't even really know it. We don't feel it. Why don't we? That's a completely different topic, and we'll get into that. But not only are we spinning, but we're revolving around the sun. We all know that. All the planets do that. And that's at 66,000 miles per hour, a lot faster. And since we've opened this 46 seconds ago, that's 900 miles that we've traveled. And then it goes into all these different things like, yes, our sun is actually orbiting a galaxy at almost 500,000 miles per hour. So it's even faster. We're going even further. So it depends on what perspective you are talking about. So motion is all relative. Um, and we defined it as a frame of reference. So frame of reference, you need to know this, is the point of view from which measurements are made. It's what's still. So we have this picture right here, and we have this cart that's moving and a person on the cart. And to that person, everything in that cart is not moving. Okay? That person thinks they're still. But to the person outside the cart, he's like, no, you are moving because the cart's moving with you. So it depends on what perspective you're from. And then we looked at this picture, all right? Cliff jumping. Coolest thing in the world. I'm going to try it. Probably hurt myself. But anyway, this dude is jumping off, doing a flip, and you can kind of see the stop motion frame he's going in. So he's the moving object. He's what's moving in this picture. All right, you got a still rock right there. So what's the frame of reference? The frame of reference, let's go back and look at it. The point of view from which measurements are made. Okay, the still point of view, something that's not moving. So let's look at this. Let's look at this picture. What's not moving? Okay, well we know that the person is moving, but that rock is not moving. Okay, so a good point of reference, a good frame of reference for this picture, if we're saying that the person is moving, would be the rock. Okay, the rock is the frame of reference. The moving object is the person. Go Browns. Baker Mayfield throws a pass. All right, let's say that the football is moving. What's a good frame of reference then? Well, if we want to know how fast the ball is moving relative to the ground is the frame of reference. All right, the ball is moving. What is still in this picture? You could choose the field, you could choose the stands, you could choose anything that's not moving, and that would be your frame of reference. All right, roller coaster nerds out there, I freaking love it. Found out that this is actually photoshopped. I feel like an idiot because I thought this was real. I really wish it was because I would ride it, but it's not. Okay, that's I think the Val Raven over, I don't know what city that is, but basically, if that roller coaster is moving, what do you think the frame of reference would be? It could be the building down there. It could be the track. It could be anything that's still in that photo. That is your frame of reference, and the thing that's moving is the roller coaster. So when you think of frame of reference, think what is still. In our last example, we got any Halo fans out there. This is from Halo 3, my game. I probably spent too many years of my life invested in this. I know this map like the back of my hand. But you got this flying aircraft called a Banshee, and it's shooting down little, I'm not going to get to the nerdy part of it. It's just shooting out people, okay? And I want to know, what is the frame of reference in this picture? So you can choose a lot of different things. What's still in this picture? What is the frame of reference? If we're saying that that Banshee, that aircraft is moving, we got to choose something that is still. And so you could choose the ground, that'd be great, a tree. You can even choose a person if they're standing still. But if they're moving, that's going to change the motion. That's going to change what perspective you're looking at that Banshee. So for example, if someone is running underneath that Banshee, then that Banshee is going to be going at different speed than if you were saying, okay, it's from the ground frame of reference. So we need to choose something that's still in order to accurately describe the Banshee's motion. So let's take a look at some examples of some word problems. This is something that you would see on a test. All right, let's do this. You are skiing down Mount Everest at 30 meters per second relative to the mountain. All right, first things first, draw a picture. Let's draw a mountain. Oh yeah, there we go. Yeah, that's a good mountain. Nice job, Ryan. And you're skiing down. This is where I'm gonna. Oh yeah. Oh yeah. Look at that. All right, and you're skiing down at 30 meters per second. So we'll go and write that on there. That's the speed that he's going at. Look at me. Wow. Nice job. And you're going down the mountain. So let's draw an arrow. So what's the frame of reference? All right. The frame of reference would be what is still in this photo. Well, what do you think? It's going to be the mountain, because the mountain's not moving relative to the skier. So the frame of reference, I'll just do frame of reference for is the mountain. And the moving object is going to be the person. We see that? So another example, you are tubing at Portage Lakes. You catch a gnarly wave and fly up in the air at 12 miles per hour relative to the water. Okay, what's moving in that scenario? Well, the person who's tubing. What's still? You can choose the water, because the water, unless it's really, really windy and wavy, the water's good. Or you can choose maybe a tree or a dock. So something that's not moving. So basically, a frame of reference is what is still, what you're saying that is still, what you're taking measurements from based on. So that sums up this lesson. Just for the test, to be able to do what I just did in that picture. So if I give you a scenario, all right, You're going to draw the picture of what's going on. You're going to identify the moving object. So here you got the skier, and then you're going to identify the frame of reference. So the mountain. All right? And that's basically the whole lesson for that. All right? All right, on to the next one.